Hey everyone, welcome to today's Explainer. We're diving straight into a bizarre logic-bending mystery hidden right in the core of one of the world's most popular programming languages. Yep, we're talking about JavaScript. Specifically, we're looking at the silent decision makers behind literally every interactive app out there. Comparison operators. You know the feeling, right? You've written a piece of logic, you swear it's perfectly sound, and the computer just does the exact opposite of what you wanted. Well, buckle up. By the end of this explainer, you're going to understand exactly why that happens, and more importantly, how professional developers avoid it every single time. So, let me throw a question at you right out of the gate. Is the number 5 equal to the word or string 5? I mean, in plain English and basic common sense, a numeric integer is fundamentally different from a piece of text. You wouldn't try to do math with a dictionary, right? It just doesn't make sense. But in the wild, wonderfully flexible world of JavaScript, the answer isn't actually that obvious. In fact, depending on exactly how you ask JavaScript this question, it might literally tell you that yes, a number and a word are exactly the same thing. Crazy, right? Check this out. When we put two equal signs side by side, JavaScript looks at the number 5 and the string 5 and evaluates this as true. It genuinely thinks they are the exact same entity. But if you add just one more equal sign, making it 3 in total, boom, the evaluation suddenly becomes false. It's totally mind-bending. JavaScript considers these two inputs equal under one rule, but completely unequal under another. It's a quirk that has literally driven thousands of developers up the wall. But don't worry, I'm going to show you exactly why the pros strictly stick to that 3 equals version and why that third equals sign is the ultimate bug swasher. Before we completely solve the mystery of the double versus triple equals, let's take a quick step back. What do these symbols actually do? Well, think of a comparison operator as a sort of digital scale. It evaluates the relationship between a variable and a value. You're going to use these constantly inside if and else statements. Really, they're the fundamental decision makers in your code. They look at a condition and boil the whole thing down to a simple binary answer, true or false. And based on that answer, they control the flow of your document. If the password is correct, true, unlock the door. If it's false, sound the alarm. It's the core logic of interactivity. Okay, let's set up a quick scenario to see how this plays out. Let's declare a variable, let x equals 5. Notice how we're only using a single equal sign here. What we're doing is telling the computer, hey, create a box in memory, label it x, and drop the number 5 inside. This is not a question, it is a direct command. We have officially assigned the integer 5 to our variable x. Everything starts from this basic assignment. Our box is packed, and now we can start asking questions about what's inside. Now that x is securely holding the number 5, let's ask JavaScript a few simple questions. Is x greater than 4? Well, 5 is obviously greater than 4, so JavaScript confidently returns true. Next up, is x greater than 5? Nope, 5 is exactly 5. It's not strictly greater than itself, so that returns false. But if we want to include the value itself, we use the greater than or equal to operator. That's the arrow right next to the equal sign. Is x greater than or equal to 5? Since 5 equals 5, this correctly returns true. These are your bread and butter operators. They're super intuitive and work exactly how you'd expect from grade school math. Okay, let's dive into this because this right here is the single biggest beginner trap in all of programming. You absolutely have to internalize this difference. A single equal sign is for assignment. It sets a variable's value. You are giving an order. The double or triple equals, though, those are for comparison. You're asking a question. Does this equal that? If you accidentally use a single equal sign inside an if statement when you actually meant to check a condition, you'll just overwrite your variable right on the spot. The logic falls apart and the computer won't even throw a warning. So always remember, single equals sets the stage, double or triple checks the scene. Which brings us right back to our opening mystery. We know we need to use multiple equal signs to compare values without overwriting them. But why two different ways? Why the double and the triple? In the industry, this is famously known as the equality trap. And let me tell you, millions of dollars and countless hours of developer sanity have been lost to it. We're about to uncover the real difference between these two and why one is treated with extreme caution, while the other is the undisputed champion of professional codebases. Let's start by unpacking the double equals. The double equals, the defining trait of the double equals is that it only checks the value of the items. It's incredibly lenient. If it sees the number 5 on one side and the text string 5 on the other, it essentially just shrugs and says, they both look like a 5 to me, and calls it a match. It does this thing called type coercion behind the scenes, forcibly converting the types so they match before comparing them. It's trying to be helpful. But in complex code, this helpful behavior creates massive, unpredictable logicals called silent failures. These are bugs that don't crash your app right away, but silently corrupt your data behind the scenes. Yikes. Now contrast that with the triple equals. The triple equals is highly strict. It checks the value and the type. Honestly, I want that phrase, value and type, tattooed on your brain. When you ask if the number 5 triple equals the string 5, JavaScript first checks the value. Okay, they look similar, but then it checks the type. It sees a numeric integer on one side and a text string on the other. Because the types don't perfectly match, it immediately shuts it down and returns false. It fundamentally knows a number is not a string. This strictness is exactly what you need to build robust, reliable logic. I absolutely love this quote from our source material because it perfectly nails the industry standard. It says, "As a professional standard, we prefer the triple equals. This checks both the value and the type, ensuring your logic is strict and bug-free. Think of it as your ultimate safety net. If you're writing code for a client or an app used by thousands of people, you do not want JavaScript making wild guesses or coercing types behind your back. You want absolute predictability. Relying on strict equality means you know exactly what your code is doing 100% of the time. It's the gold standard for a reason." So, what if we want to completely flip our logic? Sometimes you need to check if a condition is specifically not true. Like, say you're building an admin dashboard and you only want to show a sensitive delete button if the user is not a guest. For this, we bring in the exclamation mark, known in JavaScript as the negation operator. Just think of it as a logical not. When you drop it in front of an equal sign, you're no longer asking if things are identical. You're explicitly asking, are these two things completely different? But wait, the exact same equality trap applies here too. An exclamation mark with a single equal sign is the lenient version. It only checks the value. So if our x is the number 5, and we check if it's strictly not equal to the string 5, that lenient version gets confused by type coercion all over again. To stay safe, we use strict negation, the exclamation mark paired with double equals. This checks that either the values are not equal or the types are not equal. By embracing that extra equal sign, you keep that strict professional standard, checking both value and type for total, unshakable reliability. And this brilliantly illustrates our complete toolkit. You've got your greater than and less than symbols purely for numeric values, so they naturally don't enforce strict typing. You've got your double equals, the lenient equality that checks values but totally ignores types, a tool you now know to use with extreme caution. And then you have the absolute stars of the show, the triple equals for strict equality and the exclamation double equals for strict negation. These are your type-checking guardians. Once you internalize this, you'll always know exactly how JavaScript is evaluating your conditions. It's a total game changer. To wrap up today's explainer, I want to leave you with a bit of a provocative thought experiment. Imagine a massive platform handling billions of transactions, like Google or your personal bank. What if their core logic relied entirely on the double equals? What if a highly sensitive user ID stored as text was evaluated as identical to a totally different user ID stored as a number? How many disastrous bugs, security flaws, or massive data leaks could silently slip through just because a number was accidentally treated as a word? The real-world stakes of loose typing are literally astronomical. Your code is genuinely only as strong as its logic. So adopt the professional standard, embrace the triple equals, and keep your JavaScript strict, secure, and completely bug-free. Thanks for joining me on this explainer, and I'll catch you on the next one.